Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. Uh, Ladies and gentlemen, today we are going to take lecture number 81 of physics, and today we are going to start exercise on the topics which we have learned in the previous lecture. So let's directly start it. Section A is MCQs, and the first MCQ is saying a wave transfers molecules, energy, matter, and force. So let me tell you that B is the correct answer of this question because wave is the carrier of energy, and that was the first sentence of this topic. The second part is water waves are being generated in a ripple tank at a rate of 5 hertz. This means that in 1 second the number of wave passing through a fixed point is how many? C is the correct answer because number of waves passing through a fixed point in 1 second is called frequency. So the frequency of this will be 5 because 5 is the frequency, so 5 waves will pass through a certain point in this question. Now part number 3. Which one of the following is an example of longitudinal waves? Waves in a ripple tank, they are circular waves or transverse waves. Light wave is also coming in the form of electromagnetic waves, and electromagnetic waves are transverse waves. So it is also not the answer. A vibrating guitar string, that is also not because vibrating guitar means that they are transverse waves. So D is the correct option because sound waves are the example of longitudinal waves. Now 4 number question is saying in air what is the wavelength. So I am writing here what is the wavelength of the sound whose frequency is 2500 hertz. The speed is given as 330 meter per second. So we are having V, which is speed, frequency, and lambda, which is the wavelength. And because we are finding the wavelength, so we will divide it by frequency. Now speed is given is 330 and frequency is given, and that will be in meter. So we are having 0.132 meter, and in this case C is the correct option. So question number 5 is saying that all electromagnetic waves have the same speed, and that is very important property of electromagnetic waves. We studied that in greater detail, that all electromagnetic waves have the same speed in vacuum, but they are having different in the different speed in the water or in the guesses. So A is the correct answer. Ladies and gentlemen, if these questions are seeing very simple to you people, then it means that you have learned the theoretical portion very well. And credit not goes to you, credit goes to me. So sometime give me the credit as well. And if you are giving me the credit, I always telling you to subscribe my channel, share it with your friends. Now we are turning our focus to section B, and in section B they given us a question. Let me zoom it because I am not seeing, my eyesight is not that much. Okay, so here they are saying that wave motion is sound waves, changes in air pressure or density. So sound waves are which type of waves? So you have to write longitudinal waves. Longitudinal waves is the type. So first one is this one. So in the B part there must be water waves, changes in position of water molecules, and water waves are transverse waves. So we are writing transverse waves here. Now the C part is dash waves, movement of one end of the rope from its position, and they are rope waves. In the rope, one point is what? That is fixed, and movement of one end of the rope from its rest position. So it is written that this is the transverse wave. So you can say now light waves, changes in its electric and magnetic field are the transverse waves. We uh, discuss that in greater detail in the last lecture, and we are saying that they are the transverse waves. So that was the whole story about the question number 1. Now we are turning our focus to a very important part. The question number 2, it is seeming easy, but when you are drawing it on a piece of paper, then it is looking absolutely difficult. How? This is easy understanding, but drawing it is taking a lot of time. So that is why I already made it for you people so that your time will not be wasted. Draw a label sketch to show the wavelength in a rope with a wavelength of 5 centimeter. Ladies and gentlemen, what you will do, let me tell you step by step. First, you have to draw a straight line of whatever length you want, you can draw it. Then you have to draw the amplitude from this location till this location of whatever amplitude is given. So I drew it of 2 centimeter. You can draw it of 3 centimeter, and you should, because when I drew it, then later on I saw that in the question they are saying of 3 centimeter, not a big deal. You can draw a line. I drew it here. You can draw it here at the 3 of the point. So you will have to draw it here. Now on the both sides of these you have to draw on an angle of this. So this must also be of 3 centimeter. I drew it 2 centimeter because I was not aware of the fact, but you have to give full concentration to the question in the CIE exam. Excuse me. Next, you have to draw a line from here. Let me draw it a line of, you can see that because they want us to find the wavelength which is of 5 centimeter. So from here to here, if you see the touching point, that is the middle of the half wave. So 2.5 and another 2.5 will give you 5. Then you have to draw it like this. You have to draw it like this and exactly in the same position. That is what I told you, that it is a bit difficult. That is a bit difficult for you because making that area is a bit difficult, and I took very long time on it to draw it for you. So if you now measure from here to here, I am showing you, then it is almost equal to 5 from here till here. That is equal to 5. Exactly the same situation is here, that if I am drawing it, so it is exactly, you can see here and here, that it is 5 centimeter, and that is what they want us to find. So you can say that from this and this, you will have to write that the wavelength is 5 centimeter, and then the amplitude is 2 centimeter. I am writing, you will have to write 3 centimeter. My job is to tell you the way. So that was the whole story about the first part of question number 2. Now they are saying that explain the terms in printed in italics. So there are many uh, terms in which the first one is wavelength. So let me explain and define that. The distance between two consecutive crests or troughs in case of transverse waves, or compression and rarefaction. In case of longitudinal waves, in case of longitudinal waves, is called wavelength, and we discuss that in greater detail. It is denoted by lambda, and meter is the unit. Similarly, the second term which is given in italic is the amplitude. So let us define amplitude. The distance on either side of the wave from its mean position is called amplitude. So you have seen that this is the amplitude and this is the mean position. So on each side there is an amplitude of the mean position. Okay, now assuming the rope wave to be traveling from left to right at a speed of, so they given us speed is equal to 0.50 meter per second, and they also given us the wavelength which we found is equal to 5 centimeter. So we have to write 0.05 meter. In this case here we found this to be 5 centimeter. So they are talking particularly about this wave. So here we have to use the formula V is equal to F lambda, and we will find the frequency. So V divide by lambda. V is given as 0.50 and lambda is 0.05, and that will be equal to 10 hertz. So that is also about this question. Now we have to talk between the question number 4. This is question number 4, and question number 4 is saying distinguish between transverse and longitudinal waves. Give one example of each. I am not wasting your time. Let me remind you that the motion of a wave in which the medium particles are propagating are vibrating perpendicular to the motion of the wave is called transverse waves, and light waves is an example of transverse waves. If you remember, I told you that there is only one word difference between the two. Let me explain longitudinal wave as well. the motion of wave in which the medium particle are vibrating parallel to the propagation of waves is called longitudinal waves, and sound waves are the is the example of uh, longitudinal waves. Okay, that's it. Next part is saying that was A part. Now they are telling us about the B part. Uh, what is meant by the phrase a frequency of 2 hertz? The frequency of 2 hertz, that is the uh, this is not, this is question number what, this is question number 4, totally different one. So what is mean by the phrase a frequency of 2 hertz? It means that two waves are passing through a specific point in 1 second. If two waves are passing from a specific point in 1 second, then we will say that the frequency of these waves is 2 hertz. That's it for question number 3. Easy. Uh, the fourth question is saying a slinky spring can be used to demonstrate both transverse and longitudinal waves motion. Describe with the aid of diagrams how this can be done and indicate on diagram the wavelength of each type of motion. Now, first of all, in this diagram we are dealing with the compressions and rarefaction. So as I wrote earlier that the distance between the two consecutive compression, for example this is a compression and this is also a compression, so this will be the wavelength. Similarly, if rarefaction we are taking in consideration, then this will also be, because there is no crust and trough in the longitudinal wave, so we are saying that they are having wavelength equal to two consecutive crust and two consecutive compressions or rarefaction, which is also known as expression. Now you know that this is the slinky and in which transverse waves are. So the distance between two consecutive troughs or two consecutive crust is called wavelength. So in both cases we are dealing with the what, with the uh, wavelengths. Now let us our focus to the other part of this question number 4. Draw sketches of the displacement distance graph of the following waveforms. Now A part is saying in this question number 4, that is the second section of question number 4. The first question, it is not labeled, the first part is A, but that was a general question, so it was still here. And now A part of question number 4 is saying that draw sketches of the displacement distance graphs of the following waveforms. Number 8, two waves have the same amplitude. Now, if you are considering here the amplitude of these waves are the same. Similarly, here is well, but they are saying that the frequency of one is twice of the other. If you can see the frequency here, when one wave is completing, you just give till here in both the cases. So there are two waves and there is one. So this frequency is double and this frequency is single. So the first example, you can see that the amplitudes are the same. The speed is also the same, but the frequency is different. And they are saying that the frequency of one wave is twice of the other. That is asked in the question. So this is one part and this is the two. So you can see that this 1 and the 2, that is equal to 1 of the frequency. So this figure is solving that question. Now we are turning our focus to the B part, and that is the B part. And B part is saying that two waves having the same speed and frequency. Now in this case the frequency is the same and speed is the same, but the amplitude in this case of one is double. You can see that the amplitude here is single one and the amplitude here is double. Now you can see that the frequencies are exactly the same as in this case. Frequencies are the same, but the amplitudes are the amplitude of this one is double than the amplitude of the upper wave. So that is the whole story about the question number 4, and I'm afraid that I only prepare till this area because this took a very long time from me. So when you are trying it, because I made it by myself with no extra help, just like these are extra help to me, and I made this one totally my effort. So the next question is very easy, but I am stopping it here because I have to make a diagram here in which there is x and y portion in the electromagnetic spectrum is given, and we have to find that area and what is the meaning of speed in vacua. We discussed that today as well, easy, but I am stopping it here. Tomorrow we will give a look to the questions, and hopefully we will try our best to complete this exercise. Thank you very much for your time. Allah Hafiz.